Hi students. Okay, today in this lecture we learning the topic is Parseval's identity for Fourier series. So in the previous lecture we completed off-range Fourier sine series and cosine series, and also in the before lecture uh, Fourier series expansion of the given function in the interval 4 intervals. Okay na? So now here continuation here, one of the property for Fourier series, Parseval's identity for Fourier series. Okay, see the first of all statement of this. So let f of x be a periodic function with period 2l and piecewise continuous in the interval c comma c plus 2l. Then integration c to c plus 2l f of x whole square into dx is equal to L into a naught squared by 2 plus summation n is equal to 1 to infinite a n square plus b n square. This is known as Parseval's identity for the function f of x in the interval c comma c plus 2l. So this is a using only Fourier coefficients of the given function, the a naught and an bn. Using this Fourier coefficient, substituting here, this right side of the this expansion is equal to the integration of the given function squaring and a squaring of the given function in the given interval. Both are equal. So this is one of the Parseval identity for the given function for using Fourier coefficients. Okay na? So this is c comma c plus 12 interval. So similarly we define the remaining different intervals, substituting c value and l value. That is the 4 intervals minus l comma l, minus 5 comma 5, 0 comma 2 pi, 0 comma 2l, and also off range intervals, off range Fourier sine series and Fourier cosine series. So also in the interval 0 comma l and 0 comma 5, all in the all intervals we also define Parseval identity. Okay, now giving some formulas are in all intervals. That is equal to, similarly Parseval's identity also can be defined in the different intervals as, so this is the first interval minus l comma l. So okay, integration only change and remaining same, minus l to l f of x whole square dx. So this is the same and in the right side. So similarly in the interval 0 comma 2l. So 0 comma 2l is equal 0 to 2l f of x whole square into dx. So right side is the same. Okay, remaining minus 5 comma 5, 0 comma 2 5 and l place lo 5 replace change. That's all. The same formula. So that is equal to the continuation the remaining intervals. So in the interval minus 5 comma 5, okay, that is equal to here integration minus 5 to 5 f of x whole square into dx, l place lo pi. Okay na? So next one 0 comma 2 pi interval, 0 comma 2 pi interval lo integration 0 to 2 pi f of x whole square into dx. So remaining same. So next for off range Fourier sine series in the first interval 0 comma l. So that is equal to 0 to l f of x whole square into dx. So off range sine series and automatically a naught a n 0 kada, only using bn, and here l by 2 off range ante minus l to l ఇక్కడ ఈవెన్ అవుతుంది కదా మనకి to right outside. Okay na? So similarly in the interval 0 comma 5, that is minus 5 to 5 f of x whole square. And f of x whole square means always even అవుతుంది చూడండి. f of x whole square అంటే ఈవెన్ కాబట్టి ఇక్కడ 2 వస్తుంది, 2 right outside. So that is 5 by 2 l by 2. So this is for off range Fourier sine series. Similarly for off range Fourier cosine series. Okay na? So that is equal to same in the interval 0 comma l interval. This is a Parseval identity, integration 0 to l f of x whole square into dx, l by 2 ikkada a naught square a n square using. Similarly in the interval 0 comma 5 interval, so 0 to pi f of x whole square into dx, 5 by 2 into a naught square by 2 plus summation n is equal to 1 to infinity a n square. Okay na? This is the Parseval identity for the given function in the different intervals. Okay, is it clear? Next one. See the problems. Okay, the first problem, use Parseval's identity to show that 5 power 4 by 90 is equal to 1 plus 1 by 2 power 4 plus 1 by 3 power 4 plus up to so on for f of x is equal to x square in minus 5 comma 5. So here given f of x is equal to x square kada. So first of all finding the series ante compulsory using the Fourier coefficients a0 an bn. Okay, now for the given function f of x is equal to x square, then using that Fourier coefficients in the substituting Parseval's identity. Okay, now so that is equal to here given function is x square. So clearly x square in the interval minus 5 comma 5 kada. Clearly in the interval minus 5 comma 5 x square is even function. Okay, only finding a0 an bn is automatically 0. Okay, so for a series of even function f of x in the interval minus 5 comma 5 is given by, so that is a0 by 2 plus summation n is equal to 1 to infinite an into cos nx. a0 is equal to this one and an is equal to a0 is equal to integration 2 by 5 0 to 5 f of x into dx. That is equal to 2 by 5 integration 0 to pi f of x is equal to x square. So that is equal to 2 by 5 into integration of x square into x cube by 3. So that is equal to here pi cube by 3 pi cancel 2 pi square by 3. So this is the a0 value. So next one finding an value. So an is equal to 2 by 5 integration 0 to pi f of x into cos nx into dx. That is equal to 2 by 5 integration 0 to pi f of x is equal to x square into cos nx dx. So that is equal to bypass method ub method 2 by 5 into x square into integration of cos sin nx by n limit 0 to pi. So derivative of x square into 2x again second time integration. So integration of cos sin nx by n. Substituting the upper limit here sin n pi 0 minus sin 0 0. Next here 2 by n common, the constant to minus 2 by n, again u method x into sin nx. So x into derivative of integration of sin ante minus cos nx by n minus derivative of x 1. So 1 is a constant to sin 2 time integration minus sin nx by n square limit 0 to pi. So 2 common n minus 2 by n common minus 4 by n pi. Substituting upper limit x is equal to pi minus pi into cos n pi by n. Next sin n pi 0, lower limit x is equal to 0. This is a 0 sin 0 0. That is equal to 4 by pi cancel 4 by n square into minus 1 power n. Cos n pi is equal to minus 1 power n. So this is the an value. Substituting in the series. So this is a Fourier Fourier series expansion of the given function x square in the interval minus 5 comma 5. Okay na? So now we have to show that the given condition by using Parseval's identity for given function x square. So this is a Parseval identity in the interval minus 5 comma 5. This is a minus 5 to 5 f of x whole square into dx 5 into a0 square by 2 plus summation n is equal to 1 to infinite an square plus bn square. Substituting a0 an bn. Okay na? And also f of x integration also substituting x square here. So continuation is so that is equal to integration minus 5 to 5 x square whole square kada x power 4 into dx. So now substituting pi. So a0 is equal to 2 pi square by 3 whole square by 2 plus summation n is equal to 1 to infinite an value. An is equal to 4 by n square into minus 1 power n whole square. Similarly, bn 0 automatically. Okay. So now integration of x power 4 into x power 5 by 5, limits minus 5 to 5. So here 5 into simplification is 2 into 5 power 4 by 9 plus expand n is equal to 1. N is equal to 1 expansion 4 whole square plus 4 square by 2 power 4 plus 4 square by 3 power 4. So this is n is equal to 1, this is n is equal to, this n is equal to 3 plus up to so on. Okay, now that is equal to here substituting x is equal to pi, 5 power 5 by 5 plus minus of minus plus 5 power 5 by 5. Here 5 2 into 5 power 4 by 9 plus same, the right side same. Next continuation is 2 5 power 5 by 5. 5 into right side same. So observing here right side and left side 5 is a cancel 1. So 2 power 4, 2 5 power 4 by 5 and 2 power 4 by 9 is right inside. Okay na? Right inside. 5 5 cancel with 1 5 cancel. No? Remaining 2 into 5 power 4 by 5 minus 2 power 4 by 9. 4 square common. From this one 4 square common. So 1 plus 1 by 2 power 4 plus 1 by 3 power 4 plus up to so on. So simplification is, so this is a 2 common, 4 square ante 16 kada ante 8. Ikkada 9 minus 5 by ante 4, 5 power 4 by 45. 4 to 4 8, 4 to 8 avuna 8 4 to 8. So 2 cancel 8 cancel 4 by 8 by 4 kada. 8 by 4 into 2. 2 into 45 into 90. Right? 2 right inside in the denominator. So 45 into 2. 90. So that is 5 over 4 by 90 is equal to 1 plus 1 by 2 over 4 plus 1 by 3 over 4 plus up to so on. This is the required result to proved. Okay. See the next one. Okay, see the next question. Find Fourier series of f of x, phi x in the interval 0 to 1, phi into 2 minus x in the interval 1 to 2. So in the interval, complete interval is 0 comma 2. So 0 comma 2 is means 0 comma L. So sorry, 0 comma L not 0 comma 2L, because this is the Fourier series expansion, not off range and only Fourier series expansion kabatti 0 comma 2 means 0 comma 2L, and also using Parseval identity to show that 5 power 4 by 96 is equal to 1 by 1 power 4 plus 1 by 3 power 4 plus 1 by 5 power 4 plus up to so on. Okay, first of all, finding the Fourier series expansion of the given function in the interval 0 comma 2, that is 0 comma 2L. So 0 comma 2L means L is equal to 1. So in the interval 0 comma 2L, the Fourier series is a0 by 2 plus summation n is equal to 1 to infinite an into cos n pi x by L plus bn into sin n pi x by L. So this is a0, this is an, this is a bn. Okay na? First finding a0 is equal to 1 by L into 0 to 2L. 0 to 2L ante L is equal to 1, 2L is equal to 2. So that is 1 by 1, 0 to 2 f of x dx. But given function is defined in two cases here. So that is 0 to 1, 1 to 2. So this is integration is also separate. So 0 to 1 f of x is equal to phi x into dx plus integration 1 to 2 phi into 2 minus x into dx. So that is equal to phi into integration of x square by 2 0 to 1, that is 1 by 2, and here phi into integration of 2 minus x 2x minus x square by 2 from limits 1 to 2. That is upper limit here 1 is 5 by 2 minus lower limit 0. Okay, second one phi into x is equal to 4 minus 4 by 2 and 2 4 minus 2. Next lower limit x is equal to 1 minus 2 plus 1 by 2. That is equal to simplification is pi. So this is a0 is equal to pi. Next finding an. So an is equal to 1 by L is equal to 1 here. L is equal 1 to L is equal 2. So that is 1 by 1 integration 0 to 2 f of x into cos n pi x into dx. So there is also integration separated, integration 0 to 1 phi x into cos n pi x into dx plus integration 1 to 2 phi into 2 minus x into cos n pi x into dx. So that is equal to bypass method phi x into integration of cos sin n pi x by n pi. Derivative of phi x ante phi. So pi is a constant, 2 time integration of cos minus cos n pi x by n square pi square. So limit 0 to 1. Second one, phi into 2 minus x cos n pi x. This is a u, this is a v. So u into phi into 2 minus x into integration of cos sin n pi x by n pi. So minus phi into 2 minus derivative minus 1 and minus phi. This is a constant cos 2 time integration minus cos n pi x by n square pi square. Limits 1 to 2. So that is equal, first x is equal to 1, sin n pi 0. Next to minus of minus plus. 1 pi is a cancel, 1 by n square pi. X is equal 1 cos n pi ante minus 1 4 n by n square pi. Next lower limit 0 ante x is equal 0 ante 0. ఇక్కడ cos 0 1 plus into minus 1 by n square pi. Second one, next x is equal to 2 కదా, 2 minus 2 అంటే 0. This is a 0. Next one, x is equal to cos 2n pi. అవునా, cos 2n pi అంటే 1. ఇక్కడ minus plus into minus కదా, plus into minus 1 by n square pi. Next lower limit x is equal to 1, sin n pi 0, sin n pi 0. Next here minus of minus plus into minus into minus plus. Cos n pi ante 1, cos n pi by n square pi square and pi cancel, minus 1 4 n by n square pi. Now simplification is all are 2 times repeated. So 2 by n square pi into minus 1 4 n minus 1. This is the an value. Next to bn value. So 1 by L ante L is equal to 1, 2L is equal to 2. So 1 by 1 into integration 0 to 2 f of x into sin n pi x dx, that is equal to integration 0 to 1 phi x into sin n pi x dx plus integration 1 to 2 phi into 2 minus x sin n pi x into dx. So similarly same, this is u into v phi x into minus cos n pi x by n pi minus pi into minus sin n pi x by n square pi square. Limit 0 to 1. Second one, phi into 2 minus x into integration of sin minus cos n pi x by n pi minus pi integration of sin 2 times minus sin n pi x by n square pi square. Limits 1 to 2. Substitute here. First one, x is equal to 1 ante ikkada minus pi cancel, minus 1 into minus 1 by n. Next sin n pi 0. Lower limit x is equal to 0 ante 0, sin 0 0. Next ikkada x is equal to 2 కదా, 2 minus 2 0, sin 2n pi 0. Lower limit 1, 2 minus 1 1. ikkada minus of minus plus cos n pi by n pi. ikkada pi cancel, cos n pi ante minus 1 4 n by n. Next sin n pi 0. Simplification is 0. These are both are cancel here. This one is cancel. So bn is equal to 0. So next continuation. Substituting. So a naught, a n, b n values in the equation 1. The required Fourier series expansion is, so this is Fourier series expansion f of x is equal to, ikkada bn is equal to 0. So there is a required Fourier series. A naught substituting and an is equal substituting. So this is a required Fourier series. Next to, by using the Parseval's identity to show that the given condition. Okay. So that is equal to here Parseval's identity in the interval 0, 2. And 0, 2L lo interval lo partial identity. So integration 0 to 2 f of x whole square into dx. L is equal to 1. So a naught square by 2 plus summation n is equal to 1 to infinite a n square plus b n square. So but 0 to 2 ka the integration same. So this is also two types integration, separating the integration. 0 to 1 pi x whole square into dx plus integration 1 to 2 5 into 2 minus x whole square into dx. ఇక్కడ a naught అంటే pi square by 2 plus summation n is equal to 1 to infinite an square, an అంటే 2 by n square pi minus 1 power n minus 1 whole square, bn 0. So this is the integration is 5 square into x cube by 3 0 to 1 plus 5 square into the expand here 2 minus x whole square కదా. Integration is 4x plus x cube by 3 minus 4x square by 2, limits 1 to 2. So that is equal to here, this is 5 square by 2. Expand the series, n is equal to 1 ikkada, n is equal to 1 అంటే 2 4 square అంటే 16 by 5 square, n is equal to 2 అంటే 0, n is equal to 3 16 by 3 4 4 5 square, n is equal to 4 0, n is equal to 5 16 by 5 4 4 5 square. So simplification is 5 square into 1 by 3 minus 0 plus 5 square into here 8 plus 8 by 3 minus 8 minus 4 minus 1 by 3 plus 2. This is a simplification, the right side 5 square by 2. So that is equal to 16 by 5 square plus up to so on. Yeah, simplification is the left side 2 by 3 5 square and okay, in the right side 5 square by 2 plus 16 by 5 square common, 1 by 1 power 4 plus 1 by 3 4 4 plus 1 by 5 4 4 plus up to so on. Now write inside 5 square by 2. So simplification right outside, totally we getting the finally 544 by 96 is equal to 1 by 1 power 4 plus 1 by 3 4 4 plus 1 by 5 4 4 plus up to so on. So this is the required result of the given question. Okay, is that clear? Yeah, this is a Parseval's identity for Fourier series expansion. So for more videos, please do subscribe my channel, like and share it. Thank you.